Alright, now let's take a look at the connections other than the limit switches on the Demon Shield version 1.1. The difference between the version 1.0 and 1.1 is the 1.1 lists the positive and negative polarity for the ones that are important, like the PWM, the spindle direction, okay, and then over here the probe, the M7, the M8. Okay, those are the ones that polarity is important. They are important. Again, over here, starting at this point, we have the auxiliary ground for the shields mainly. We have the limit switch. This one's X, limit switch Y. And here we have the PWM. PWM is the pulse wave, I believe it's modulation. It sends out basically a smart signal, if I could call it something, to a device that can use it, like the IoT relay. Back here is an IoT relay, and there's a input on the side of it that would get connected to the positive, negative here. It can be very small gauge. It doesn't have to be big at all. It's a very low voltage signal. Okay, and it looks like a square, basically, the wavelength of it, and it changes that based on parameters in your gerbil settings. That is for the max and minimum RPM. Okay. It would go 0% basically to 100% based on your spindle code, your speed code, the M3 S, and then whatever, and whatever that S number is based on your minimum maximum is going to be what this puts out. So if your maximum was 100 and you put a spindle of or a S code of 50, it will be 50% power going out, which would not trigger a relay, just so you know. Okay, so when you're dealing with triggering relays with a PWM, you always want to max it out. So your S code or your RPM in your toolpaths should always be maxed out at whatever your RPM max is in gerbil. Okay, then we have the Z limit, and then we have a spindle direction with plus and minus noted. This is for, I believe, VFDs use this. Okay, you're not going to really use this too much. There is a version of gerbil being developed right now, or in its beta testing phase, that would allow you to have two sets of limit switches, or two limit switches, one for each y-axis, and you would actually be able to automatically square your carriage, and it switches one of the like the Y2, not the enable, but the direction and the pulse. One of those is here, and I believe it switches something over to here. It ends up using one of those two, but normal gerbil does not. Over here we have the probe, again with the plus and minus noted. One for your touch plate, one for your alligator clip to go onto the bit. We have the M7 and the M8. Those are for cooling, okay, mist and flood, for relays that you would have attached to systems for cooling. You could also trigger another relay for a dust collector or whatnot with those. The M9 would shut that off. Okay, both of them. So if you have the M7 on, M9 is just going to shut that off. If you have the M7 and 8 on, M9 is going to shut both of them off. Next up is the three analog controls. On the website, I have some parts for you to print if you'd like to make something like this, an enclosure for the analog buttons. I also have a version that puts a plug connector here to extend your probe. So you can mount this. There's 3 ways to mount it. There's holes on all sides. You can top mount it, you can front face mount it, or you can mount it underneath like this. Okay. And then on the one with the probe plugged into there, and then you could use it and unplug it when you don't need it. Okay. They are just for push buttons. They connect. It doesn't matter which one is plus, which one is minus. As soon as these pins connect, it trips it. Every Demon controller I send out, I test these, and they work instantly. It's not like in the software where you pause it and it's got to finish eating up the code that it's already sent and buffered onto the Arduino. These will kill it right away. These will pause it or resume or abort immediately. I suggest you never use an e-stop button, okay, connected to the power end of this stuff. I suggest, for sake of keeping the backfeed circuits, the protection circuits, active, you need the power to stay onto them. As soon as you kill power to the drivers, all the protection circuits are gone. They're not doing anything. You can still fry drivers. So what I suggest is you connect that E button. If you're going to use an E button, connect to the abort instead, right here. Okay, it will still stop that machine dead in its tracks. It'll still turn off the spindle. Some versions of Gerbil, it'll actually raise the spindle up out of the way when it gets stuck. Okay, I believe what I read was ones with positive, that's called the parking, like a parking feature. Ones with positive space, machine space, does not lift the spindle up. Apparently there's some thing in Gerbil that just won't, you can't have both. I prefer the ones that are positive. So in those ones, what ends up happening is it'll kill the spindle. If you have it on a relay, it'll kill the output to that, and it'll stop all the motors dead in its tracks, which is just fine. And that there is all the connections on the Demon Shield. Okay, and this is how it sits on top of the Arduino. And then here is the cover that either comes with the Demon controller, if you buy a full-blown Demon controller, or the files are available to print yourself right on the website. They have tabs. Those tabs get printed on their side. This gets printed upside down like this. Put some super glue in there inside the little pockets here. Put your Demon Shield on there, and then just slide the tabs down till it touches the Demon Shield, and then just let it sit for you know, an hour or so. Let it really fully set up, and then you can take it off and then connect everything. And that just plugs onto here like this, and sits nicely on there once it's all seated. Alright, and that's the connections on the Demon Shield.